Well, this is a paper called Mergers and Acquisition, Technological Change and Inequality. And this is joint work with Wenting Ma at Amherst and Elena Simonitzi, also at the University of North Carolina. So M&As are an important mechanism through which new technology is adopted by firms. And this really goes back to the original work by Gort. So in his original theory work, the argument he made is that when new technology is available, not all firms will immediately adopt it. And his argument mainly rests on the fact that in order to adopt the technology, firms are going to need some other complementary skills, presumably some amount of human capital. And so what he envisioned is that those firms that have this complementary human capital will be able to adopt the new technology. They will become more productive. Other firms won't be able to adopt the new technology. They'll stay at this constant level of productivity. And then over time, the more productive firms with this new technology will acquire the other firms that weren't able to adopt the technology, and then following the M&A will adopt the technology. A similar argument is made in Bartelsman and Doms. And so in that paper, they talk about different frictions that would stop firms from adopting technology that would otherwise increase productivity. And the main ones that they focus on are these idea of agency conflicts at the firm that are preventing the firm from adopting some form of technology. And so why should we care about this? Well, we argue that this matters because if following an M&A, there is this increase in adoption of technology, this is going to have important implications for labor. And so when we think about the implications for labor, we're thinking of two main facts. So the first one is that technology and labor could be complements. So this is the standard skill-biased technological change argument that with additional technology, high-skill workers are going to be more productive. And in that case, this is presumably going to lead to the firm wanting to increase the share of high-skilled workers. And then the other is that technology can be a substitute for certain types of workers. And in particular, if we think about what technology can do, you know, any form of automation, what it's good at is doing things that come in a specific pattern, something that's routine. So presumably, automation can best replace workers who are doing some sort of routine tasks, and we refer to this as routine-biased technological change. And in this sense, we think as firms adopt more technology, we're going to see a decrease in employment of workers that are engaged in highly routine activities. So what we're going to do in this paper is we're going to look at the ex post labor reallocation at target firms. And what we're going to document is some changes to both labor reallocation. We're also going to be looking at wages. And we're going to find that these changes are consistent with the target firm adopting greater technology. Okay, so to make sure that my motivation is clear, I want to go through three specific mechanisms through which we would expect to see this greater technological adoption following the M&A. And the first one, this efficiency of adoption, comes straight from Gort. So this is exactly his argument, that there are some firms that are just going to be good at adopting this new technology. They're going to be the first ones to do it. What they can do is now go over and acquire the other firms that haven't adopted the technology and then more efficiently implement the technology at the target firm. The second one comes from sort of this idea of thinking about agency frictions. And the main one that I have in mind here is, again, thinking about that some of this technology can be used to replace workers engaged in routine activities. What this means is that there could be a technology out there that is efficient for the firm to adopt. It'll increase productivity, but only will it be cost effective if the firm also fires a certain number of workers. And we know from existing studies that CEOs don't like to fire existing workers, particularly if they've sort of developed emotional ties with their employees. On the other hand, a new CEO coming in who has no relationship with the existing employees may be much more likely to fire these workers and adopt the technology. And then the final mechanism is an increase in scale. And this just comes from thinking about the economics. So if we think about the idea of some sort of task that can either be done by technology or be done by labor, then thinking about the option to do it by technology. This is typically going to come at a higher fixed cost than employing labor, but at a lower operating cost. And in a lot of cases, this technology can be almost infinitely scalable. And so what we would expect is that if you were a firm and there was some technology out there, and this could potentially replace maybe 12 employees you have in a given occupation, then it may not be cost effective to adopt the technology today. But if you acquire a target firm and now you have 20 employees in that given occupation, now it may be cost effective to go ahead and adopt this technology. And so in terms of our predictions, with regards to the labor market, we are going to have three main predictions. And the first one is, as I mentioned, some of this technology is going to be a substitute for workers, particularly workers engaged in routine tasks. So what we're going to do is we're going to measure the routine task intensity of the labor force at the target firm, and we're going to expect to see that decline. On the other hand, this is going to make the high-skilled workers more productive, which should make the firms want to employ relatively more of them. So we should see an increase in the employment of high technology workers. And then we're also going to have two predictions for wages. So these routine workers that we expect to exit from the firm tend to have wages sort of in the middle of the wage spectrum. On the other hand, we expect to observe an increase in high technology workers, and we expect these workers to be more productive. So on average, we expect wages to increase. But mainly our predictions are going to be about wage dispersion. And because what we're going to be predicting is that the wages are going to increase for the high-skilled workers. These are the workers that already had the highest wages. And so what we should find more than necessarily an increase in wages is going to be this increase in sort of wage polarization. So I'm guessing this might be a good place to stop to see if there are any questions.
At this point, there are no questions yet.
Awesome. So in terms of the related literatures, there is certainly a large literature that looks at what happens to labor markets following an M&A, and I feel like we add into this literature. Where we're going to differ from the existing literature, I think, is our ability to look into sort of finer detail of the workers and really to be able to separate by these occupations. And so what we're able to observe here is a bit more of a nuanced story than I think has been said in some of these earlier papers, that the M&A is going to have positive or negative impacts for the target's labor force depending on the type of worker. This can lead to better opportunities for the high-skilled workers, but it's likely going to decrease the employment opportunities for the workers engaged in highly routine activities. And then the other literature we're going to directly relate to is the skill bias technological change and the routine bias technological change. And within this context, what our results are going to speak to is that M&As can act as one of the catalysts through which this technological change is being adopted by firms into the economy. So Ryan, any questions now, or shall I keep going?
Yes, there are two questions. First, why wouldn't a technological leader simply scale up without the need to acquire another firm? Is it because there are some specific externalities from acquiring firms?
So I think this is a very good point. We are not trying to make the argument that the only way this technology is going to get into the economy is via M&A. So I think this argument that the questioner has in mind absolutely makes sense. The technological leaders are going to invest in all this technology and they're going to scale up. But what's going to happen is that if they are able to efficiently implement this technology, there's going to be these other target firms out there that aren't able to efficiently implement this technology. They're therefore going to be less productive and presumably be trading at a lower cost. And so it could be cost effective for the acquirer to go in, buy this low technology target, and then increase the technology at that target firm and increase its productivity and hence its value.
Okay, second question. Your predictions seem to focus on cost synergies, savings from reducing redundant costs. Do you think technology is related to revenue synergies? An example would be the creation of new products using technology.
So this is a very fair point, and this is something that we have struggled with, because at the end of the day, we can't really separate between sort of how you're optimally using your labor and how you're optimally using your assets. So I think what we're trying to look at here, which is adding to this giant literature on M&As that thinks about all the different benefits and changes you can have ex post, is trying to understand what are the implications for employees from technology coming in. I don't think we can speak more broadly about what this means for sort of developing new revenue sources. I think that would be interesting, but probably beyond the scope of our paper.
Okay, a couple more questions. Can you separate wage effects from technology versus from the labor market or monopsony effects?
So in terms of looking at it from monopsony effects, we probably could do something. In the current draft, I'm afraid I'm not going to be able to show you anything, but that is a nice question. And what we could do is look within smaller labor markets and see if we see different effects. Right now, I'm just going to be able to show you mean effects. We're going to argue it's consistent with technology again, because we see these direct predictions out of skill biased and routine biased technological change, but it's all going to have to be inference because we're just going to be measuring changes in the labor force.
Okay.
But that's a nice thing to think about for our next time we go back to the data.
A few more questions have come in. M&A is beneficial for many other reasons than the inefficiency of the target firms implementing the new technology. Those benefits could also lead to the same outcomes as the ones you listed. For example, changes in wage and labor intensity. How could you disentangle them?
So I would think that this general idea of what are some of the gains you're going to get from the merger? And I think there's been an argument that's out there that says that once we do a merger, we can therefore reduce employment redundancies, and that can be one of the gains from the M&A. And I would think of our paper as being very complementary to that story, and in fact, possibly explaining the exact mechanism through which that story works, in the idea that if we think about sort of this redundancy story, what we're saying is, before the M&A, there were two workers that were doing very similar jobs. Post M&A, one worker can do that job, and we can fire one worker and get the gain in the cost savings. I would argue, well, why can one worker now do two jobs? And I would think that the main reason one worker can now do two jobs is through technology. And so again, going back to thinking about, well, what are going to be the other implications of the technology of the target firm? So we're going to show those other predictions on sort of the general labor force. But we're not going to be able to exactly separate between those two, as I think they're, I guess, at some level, the same argument.
Okay, there's a suggestion. One way to disentangle the revenue effect from the cost effect can be to look at the constituents of total factor productivity.
Unfortunately, in our data, we don't have access to anything equivalent to TFP. So what we're going to observe here is we're going to have beautiful data on labor, but that's going to be it. I'm going to have no information on sales, let alone investments in physical assets. So I will get into that later. I agree, that would be very nice. Unfortunately, this is using BLS data that doesn't have some of this census level data.
Okay, that's the end of the questions.
Awesome. Thank you, everybody, for these great ideas. Okay, so the data I'm going to use. So the M&A data is quite straightforward. So this just comes from Thomson's SDC. We're going to use it from 2001 to 2017. We can only start at 2001 because of this other data we're going to use. In the results that I'm going to be showing, I'm going to focus on horizontal only deals. So the acquirer and target are going to be in the same industry, and focus only on target establishments. We do this because this comes straight out of that original motivation from Gort, where the target had not adopted the technology and now is being acquired and the technology is going to appear there. We do have some results looking at non-horizontal deals and some results looking at acquirers. If I have time, I will present them, but keep in mind the main results I show you horizontal target establishments. In terms of the employment data, This comes from the Bureau of Labor Statistics, and this is their Occupational Employment Survey, the OES. I always put a pitch in here for BLS data because I think this is generally underutilized in finance, and this is great data, and the BLS is actually quite easy to work with. So if you are interested in getting access to this micro data, you should be able to find everything online. If you can't, always feel free to drop me an email. You do have to submit a proposal. Generally, it's sort of wait a year. And then the big cost is you do physically have to code this data in Washington, D.C. in the BLS itself. But beyond that, they're very easy to work with. And what the OES data is it is establishment level data. So this is going to be every single physical location where the firm has at least one employee. And then for each of these establishments, I'm going to observe information on the count of employees per occupation. And occupations are going to be defined by what's called the SOC codes, the standard occupational codes. For those of you who are not familiar with these, very similar to SIC codes, but they're based on occupations. So what are the tasks that you're doing in your job? And we have 800 different unique SOC codes. So software analyst would be one of these SOC codes. And then for each establishment, we will observe not only the count of software engineers, but we will observe the count of software engineers in each of 12 different wage bin groups. So we don't observe directly the wages, but we observe wages divided into 12 groups, and then the count of workers per occupation in each of these different wage bins. And then in order to measure technology, we're going to use what's called the Computer Intelligence Technology Database, the CITDB data. So ideally, what we want to measure here is automation. So all forms of automation. I would love to tell you that I have great data on automation. I don't. As far as I know, there is no great data on automation, but please interrupt and share or tell me if I'm missing something. So some people have looked at robots. I think that's one very interesting way to look at it. You know, it has its benefits, it has its drawbacks in the sense that robots are particularly relevant in some industries and maybe less relevant in other industries. What we are measuring with the CITDB data is IT spending. So when you look at these estimates on IT spending, don't think that every single dollar you're observing here is a dollar spent directly on automation. But our argument is that if you want to increase automation, you also have to increase IT. So we're going to use this as a proxy for automation investment. And it has been used in this way by earlier papers. And so I cite a couple of them down here, most recently Bloom, Draka, and von Riemann. So the OES data, so this BLS data is beautiful and wonderful. One issue with it is matching in your firm names. So in order to do this match, remember the BLS data is going to be at the establishment level, and it's public and private firms. So it's this massive database. So matching in the firm names from the SDC is a very time intensive. This was months of work, but we match it in by either firm name and EIN or some combination thereof. We keep only those establishments that are involved in an M&A and that we can observe at least twice. So we have sort of the pre-M&A observation and the post-M&A observation. And then for each of these treated establishments, we're going to identify one control establishment. That control establishment is going to be operating in the exact same industry, the same year, and then we're going to pick the control establishment with the nearest employment size. And in the end, we're able to match 1,740 M&A deals, and this is going to involve 5,014 unique target establishments. Ryan, should I answer a couple questions now?
Yeah, there are some questions related to data. Are SOC codes updated periodically to reflect new technology like SIC codes?
They are. The issue is that so it's going to impact how we're going to measure routine intensiveness. So while SOC codes are going to be updated over time, our measure of routine intensiveness is going to map each SOC code to a sort of a value of routine intensiveness for that SOC code, and that is entirely historic. So to do this, we just directly pull from Otter and Dorn's AER paper where they do this, and we follow exactly their code. But it is going to say that there are going to be some new occupations that are coming into the world. We are just not going to measure them. And so we just drop them. They're not going to be observed in our numerator because I can't identify how routine they are. And we're just also going to drop them from the denominator.
Sorry, I was muted. So yeah, so the follow-up was, if they're stale, how would that affect your results?
My assumption is it would add noise. As of now, I don't know of a better way to do it. And at least this makes us comparable to sort of the existing studies that work on routine biased and skill biased technological change. But that is a fair critique of the paper.
Okay, isn't there an endogeneity problem since firms might merge or acquire with the intent to innovate or synergize? An alternative could be to merge or acquire with the intent to kill the acquired firm, thereby stifling competition. Are you trying to find a causal effect?
So what we would argue is that these are mergers that are done absolutely with the intent of adopting technology ex post. Now, it's probably not the only reason for this merger. I mean, mergers usually have a lot of different reasons as part of it. But when the merger was decided upon, the assumption would be that there is some gains that are going to come from adopting technology at the target, and that is part of why the acquiring firm is willing to pay the transaction cost to do the merger. So I think the big concern we are going to have in terms of this paper is going to be whether or not there is an omitted variable that could also drive M&A activity and simultaneously drive labor reorganization. And so that is certainly sort of the big concern in this paper. And I'm going to go through a couple different ways we're going to address it. You know, I think the strongest evidence we have is that if I think about sort of these common shocks that would drive merger activity, I think about industry waves of M&A activity. And so one thing we can do is we can include industry year fixed effects. And what I can show you is, well, industry year fixed effects are not perfect. They're not going to absorb this entire story because we know industry is measured noisily. But if it's really being driven by these sort of industry waves, these common shocks, then I would expect this is going to have a significant impact on my ability to estimate this effect. But once I throw these in, the coefficients don't move very much. On top of that, we're going to look at canceled deals, and we're also going to look within establishment years, but I'm going to have to get to that at the end.
Okay, there's one more question. Acquisitions under this paradigm are positive NPV ventures for the acquirer, but the M&A literature doesn't see a clear value creation for acquirers. How do your results relate to value creation?
So one of the things we do want to add is M&A announcement returns. But one thing I should be clear about, and maybe, no, it's not on this slide, is we are looking at M&As of both targets that are both public and private. And so the M&A literature on acquisitions of private targets does have a clear summary statistic where this does lead to value gain. And so we have, oh, I wish I could remember exactly how this falls out, but I believe we have at least half of our sample are private targets. So in that sense, I wouldn't necessarily predict a negative stock price or value creation. And again, I would think of this as M&As are argued by all sorts of different mechanisms. We're not going to try to separate all of those. We're just saying one mechanism that could be part of what drives some fraction of M&As is this investment in technology. It's not going to be there in every single deal. We're going to measure it with noise. But we are measuring consistently this increase in technology investment and these changes in labor that are consistent with the increase in technological investment.
Okay, that is the end of the questions at this point.
Okay, so just to give you a quick sense of our M&A deals, we are observing these across all different types of industries. And our standard empirical estimation is just going to be a standard diff and diff. So here, the key variable of interest is going to be this gamma 2, which is going to measure that interaction of after the post period and whether or not you were actually one of the M&A, one of the treated. In these regressions, we're going to always include controls for year fixed effects. So to control for any differences across time, we're going to control for establishment fixed effects to absorb any differences time invariant in the M&A establishments. And then we're also going to control for time varying establishment characteristics. And there what we're going to control for is the fraction of occupations at your firm that are offshoreable. And then everything we do with our standard errors, we'll cluster those at the firm level. So before I get to the results on labor, I do want to quickly show some results looking at our investments in technology. And so what we did here is we just take this as the data from CITDB, and what we take is IT budget. So how much are you spending on IT in total at the target establishment? And then we take the three main components of the IT budget: hardware, software, and services. All of the regressions are the same specification: establishment fixed effects, industry year fixed effects, and state year fixed effects. All of the Y variables are log transformed. So when you look at column 1 and you see this coefficient of 4.8%, you can interpret this as a 4.8% increase in the IT budget each year at a target establishment following the M&A relative to a matched control establishment. And we're going to see the same effect when we look across these different components of the IT budget. But one thing before I move past the slide, I do want to emphasize the CITDB data does not go back in time as far as our other data sources. So unfortunately, we are only able to look at the CITDB data between 2010 and 2015. So this is going to be a slightly different set of years than we're going to look at with the OES data. And because both of these data are survey data, they're not directly overlapping. So this data set and the OES data are going to be different data sets, but we will also show you some results where we combine the two. Now, one concern you might have looking at this is, okay, maybe IT budgets are increasing, but maybe it's just the target establishment size is increasing. So we can also normalize it. Here I'm showing it normalized by employment. We could otherwise normalize by sales. We're going to get very similar results. So we continue to see this increase in IT, and here it is an increase in IT per employee we're observing post M&A. So consistent with this argument that these firms are adding additional automation following the M&A, and in order to do that, they also have to increase their investment in IT. Okay, so now let's get to the key results of the paper, which are looking at these changes in labor. So one of our key measures is going to be this routine task intensity, which I've alluded to a bit already. This comes straight from Otter and Doran, their 2013 paper. And what they did is for each occupation, they go back to the original Dictionary of Occupational Titles published by the Department of Labor, and they read the definition of what that job does, and then they code for it. How routine is this? How abstract, how manual is it? And then they come up with a final code for that occupation. We match that into our data on occupations, and then we just simply take an employee weighted average for the establishment. Share high tech. We get this from a BLS publication that identifies those occupations that are deemed to be high tech occupations. So this is going to be anyone active in the computer, information systems, engineering, math, or natural sciences. It's going to include low-level employees in these things, as well as sort of scientists and managers in these different occupations. We're going to measure wages as the average hourly wage. So remember, we don't observe exactly wages, we just observe the count of employees within bins. So what we're going to do is we're just going to take the midpoint of all of these bins and assign that as the wage for the employee. And then our one-time varying firm level measure is going to be offshoreability, which also comes from the same Otter and Doran paper. Again, it's mapped in at the occupation level. And this is simply a measure that they calculated, which is given a certain occupation, does this need to be done face-to-face, or is this something that could be done remotely? And so we'll control for that in all of our main regressions. So just quickly to look at the summary statistics, in the first three columns here, you will see establishments that are our matched control sample, and in the second batch of 3 columns, you're going to see the establishments that are treated. And then in the final column, you'll see the p-value of differences in the mean. What you'll see is that the treated and control look statistically similar. And this is true in terms of ex-ante, RTI, employment, share of employees that are working in high tech, wages, standard deviation of wages, and offshore ability. But 2 things I want to emphasize before I leave this slide. First is that the OES data by the BLS oversamples large establishments. And so that's what you're going to be seeing here. So for example, the mean employment size of an establishment for our matched control sample is 139 employees. This is a big establishment. So, you know, the median establishment in the US is about 6 employees. So we are estimating the biggest establishments, and the OES does this intentionally because they're using this data to aggregate up to US statistics, and it's more important to estimate accurately the big establishments. But I think it's also valuable for us because we know that we're measuring the establishments that matter in the economy. But besides that, everything here is going to be very similar to national statistics. For example, if you look at average hourly wages, this is in 2001 dollars, 16.55 is the mean for our control sample. In 2001, the US mean was 16.4. So otherwise, this really looks like the US statistics. Okay, so here is my first regression. Ryan, should I answer a question or 2 first?
Yeah, you've got a few that just came in. So first, wouldn't an increase in IT post-merger be partly a result of the effort to integrate the target into the acquirer?
I absolutely agree. That's why I think this result, if it wasn't there, I would be very worried. You know, all of our results sort of follow on the argument that technology is increasing. But I don't think we can look at the result that technology increases and argue that we should then necessarily expect all these labor effects.
Okay.
So certainly part of this is integration spending, and I can't separate between the 2.
Have you also tried scaling dependent variables by assets?
So in the CITDB data, I observe sales and employment, and that's all I have. And then once I'm now in the OES data, I don't observe sales. I observe employment, but I will never observe sales again. Okay.
A question about the high R squareds. Can you explain which variables or fixed effects lead to those high R squareds?
The establishment fixed effects. So remember, we're looking at about 137 employee establishments. In terms of measures of RTI, the way that is moving is if you're firing some workers and hiring new ones. There's not a lot of change over usually a 3-year period.
Okay. Would you know whether your M&As are in related or unrelated industries? My instinct is that technology is likely to make greater difference in related acquisitions. Unrelated acquisitions may be because of non-technology synergies. Sorting on that may strengthen your results.
So absolutely. Thank you for that. These are all horizontal deals. So I don't think I'm going to have time because I'm getting so many questions. We have looked at non-horizontal deals, and exactly as you predict, we find stronger results with the horizontal deals. But because of the same motivation, we started just looking at horizontal deals. This is where we expect to find the most traction.
Okay, more questions coming in. I would have thought that the pre-merger OES summary stats would be different because acquirers would see bigger gains from adopting technology if the target had more TRI and less high-tech employment. Why is this? Sorry, RTI, not TRI.
So I completely agree, and we actually have run a test doing sort of a conditional logit and seeing whether they do have lower RTI in that setting. You know, depending on exactly how we specified it, we could get some weak results, but nothing strong enough that we felt we could go forward with. I think it's there. I think it's hard to be able to tease out because in order to write that test, I have to really predict, well, who otherwise would you have acquired? But absolutely, we have tried that. We get some results similar, but nothing that I would think statistically strong enough that we wanted to put into the paper.
I think this next question is similar, but let me read it anyway. Isn't it surprising that treatment and control group are similar on high-tech employment and RTI? In the story of more efficient firms take over less efficient ones, shouldn't we expect that acquirers target firms which are lagging behind in terms of technology?
So interestingly enough, we actually did not look at this in terms of high technology share. So I will add that to the list. I don't know why we didn't think of it to look at it in terms of high technology share, but absolutely, maybe we'll get stronger results there. That would be good.
Okay. Do you think the impact on onshore U.S. labor would be different compared to the impact on offshore labor of the acquired companies? Is there data available on this?
I mean, I think this whole idea of onshore contract work is huge and is something that I would love to be able to say that I have data and could estimate. We don't have any data on it. Whether it could be explaining our results, I mean, you would have to assume then the workers that are disappearing, that are in the high routine, are going to be the ones who are going to be onshored into contract work. So to be clear, if an employee is still physically working at the given establishment, but is not working for that firm, is now part of a contract employee, like a cleaning service that comes in, we won't observe that employee as being part of the labor force at that establishment. I don't think it can explain our results, but I do think it is a very important economic phenomenon, and I wish I had data on it.
That was the last question.
Awesome. So here are the results looking at routine task intensity. I'm going to use these same 4 specifications going over and over again, so I just want to be clear on them. Column 1 has year and establishment fixed effects. Column 2, I'm adding the control for offshoreability. Column 3 adds industry times year fixed effects, and column 4 adds state times year fixed effects. So across all 4 specifications, you're seeing this negative impact on routine task intensity following the M&A at the target establishments. And as I mentioned earlier, I find it comforting that adding the industry year fixed effects does not have a dramatic impact on our estimates of our estimate of interest, this post times M&A. And if you want to think about the economic magnitude, this is about a 3.4% decline in routine task intensity relative to the mean. But one thing I do want to emphasize is this is in a short window following the M&A. So on average, that post year is about 2 years after the M&A occurred. So there could be even more dramatic changes down the road. The other thing, and this has already been brought up, this is a correlation, absolutely. So when we get a little further into the paper, I'm going to try to make more arguments that we believe this result is causal, but as of now, all I'm showing you are correlations. So the other key labor reorganization prediction we had was with the share of high-tech workers. Again, the exact same 4 specifications, and what you're observing here is an increase in the share of high-tech workers. It holds across all 4 of these specifications, and this is even economically larger. So we're seeing a 16% increase relative to the mean in the share of these high-tech occupational workers. So sort of one point I just want to emphasize, this is suggesting this sort of nuanced impact of M&As on labor. So we're seeing a decline in the share of employees who are working in routine jobs, but we're seeing this increase in the share of employees working in these high-tech jobs. But what I've shown you so far is a share. And so sort of I think one fair critique would be like, well, Paige, you can increase the share of high-tech workers by just firing everybody else. So is it really that they're adding high-tech workers, or is it just that they're not firing high-tech workers at the same rate as they're firing other workers? And so we look at that here. So in the first regression, I just have the total count of employment among high-tech workers. And then in the next 3 columns, I divide into the 3 main categories that exist within this high-tech employment: computer science and math, engineering, life and science. Same specification across all, which is our most robust with industry year and state times year. And what you see is if I look at employment levels for all high-tech employees, I see a positive effect, but it's not statistically significant. On the other hand, if I look within these subsets, there is a really strong effect if I look within engineering employment. So there we see a very large increase in employment in engineering jobs. So the way this has been explained to me is that the CS and math occupations tend to be the occupations associated with novel innovation. So these are the occupations that are much more likely to lead to patents, to actually develop the technology, while the engineering employment, which we're seeing in column 3, are the type of occupations that are going to be more likely to be associated with implementing the technology, which is more consistent with our story. So it is not that the target firms are innovating more following the M&A, but they're implementing more of this new technology that some other firm has previously innovated. So now that I've shown sort of the baseline results for the labor reorganization, I want to talk a bit more about the different mechanisms and see if we can isolate sort of specifically what are the channels through which this is happening. And we have 3 non-mutually exclusive mechanisms. And the first one is this idea of operational efficiencies. So the argument here is that the acquirer is much better at adopting technology once it takes over the target firm, given its sort of competitive advantage in adopting technology, it's going to be able to increase the technology at the target firm at a relatively efficient cost. And so the way we're going to proxy for that in our data is using that CITDB data that I showed you earlier to measure how IT intensive is the acquirer prior to the M&A. And so we're going to predict that there's going to be bigger labor market reorganizations at the target when the acquirer in this specific deal has a lot of IT. The second story is this agency story. So the idea that there's some sort of agency frictions that exist at the target firm, and this is preventing the firm from adopting technology that would otherwise increase productivity. We have gone back and forth many times on how to measure sort of the agency frictions at these firms. And again, with the OES data and private targets, we don't have a lot of data. So what we ended up using is unsolicited deals. We don't have a lot of unsolicited deals, so I think of this as sort of a weak power test. But our argument here is that if the deal is unsolicited, it's more likely to be addressing some sort of agency conflicts at the target firm. And then finally, with these economies of scale, our argument there was that we should see more technology and hence more impact on the labor markets if the acquirer and the target have these overlapping occupations. And so here we just simply take the acquirer observations, we identify all the occupations in the acquirer that we observed in the previous 2 years, then we go back to the target, we observe all the occupations there, we see how many of these overlap, and then we simply measure is the overlap high or low. And we expect to have greater effects if the overlap is high. And so the first results are going to be the interaction with acquirer IT. And as predicted, we're going to find stronger effects when the acquirer has higher level of ex-ante IT. When we look at unsolicited bids, we find a significantly stronger effect in terms of RTI. So routine task intensiveness declines even more. In terms of share high tech, we have a point estimate that's positive, sort of consistent with more of an increase in high tech workers, but it's not statistically significant. Again, I think this is a weak power test. And then finally, with the routine occupation overlap, here again, we're going to find evidence of sort of stronger effects. So there's a more dramatic decrease in RTI and a stronger increase in the high tech share. So moving on to wages. So first, our stories were about these labor market reorganization, but they're going to also have implication on wages. And so one prediction is just simply an average increase in the average mean wage. So again, we're getting rid of some workers in the middle of the income distribution, the routine task intensive workers. We're hiring more high skill workers, and those high skill workers, all of them that we have, are becoming more productive. So putting this all together, we should expect on average wages to increase using those same 4 specifications from earlier. And this is average hourly wages. So it's not going to commingle any effects of sort of longer hours being worked following the M&A. And what you see is an increase in wages. We're logging wages here. So the economic interpretation, if we look at column 4, this is an increase in average wages of 1.25%. So it's not a dramatic increase, but we are seeing an increase in wages. Where I feel like we have a much stronger prediction is in this polarization of wages. We're going to expect to see more unequal wages because we think it's the high-skilled workers that are going to see all of the wage increases. And so what we do here is we measure the standard deviation of wages. Again, the same 4 specifications. And again, across all 4 specifications, we're seeing this increase in standard deviation of wages at the target establishment following the M&A. Now, we use standard deviation of wages as our main measure. More common in the literature generally, at least looking at sort of macro trends, is to use things like this 90-10. I think it's a little contrived in our setting because remember, I don't actually observe the wages. What I observe is sort of these counts by wage bins, but we can create 90-10. I mean, we can identify where workers are and we can redo this. We find consistent results if we do this other approach. So again, if we do it in 90-10, if we do it in 75-25, and even if we do it in 90-50, although there is a decline in the magnitudes, whether it's economically significant or not, but we are seeing sort of a weaker effect when we think about 90-50. And just to think about the economic magnitudes of the standard deviation, this is about a 4% mean increase, about a 3% increase in the 90-10 and the 75-25, and about a 2% increase in the 90-50. So Ryan, is this a good time for questions?
Yeah, we've got several questions. First about the control group. M&A is generally a type of investment. Is it possible to restrict control firms to have the same level of investment or growth? Otherwise, we might be comparing firms with high and low investment. In particular, during the past 20 years, a significant portion of investments, M&A or otherwise, could be for technology adoption.
So unfortunately, in the OES data, I'm not going to directly observe investment. I think in a couple slides more, I'll show you pre-trends. That's really sort of the best that I'm able to do. But what we probably could do is we could look just within maybe the public targets and match those to other public targets and use CompuStat data to ensure that they have sort of a similar ex-ante trend. And that's certainly something we could try to do.
Okay, there are 2 more clarifying questions. First, do the results suggest that the firm decreases non-engineering employees but increases engineering employees given the overall insignificant change after M&A?
Yes, yes. We've looked at employment. So with all of these arguments, there's not a direct prediction for employment. It could be that employment decreases because again, you're replacing some of these routine workers, but if it makes the rest of your workers more productive, it could be employment actually increases. We did at one point look directly at employment and I believe we find a negative effect on employment, but either way, if you just compare some of these results, it has to be that employment is declining in non-engineering.
Okay. Do the wage results control for changes in the occupation composition of firms?
No. So the wage results that we're observing, I would assume, are primarily driven by changes in occupation. So this is not like the LEHD census data where I can observe there's like a 1% increase for the same worker. I'm just simply saying, here are the workers I observe ex ante, here are the workers I observe ex post. On average, for the ex post workers, the average wage is higher. And yes, I expect most of this is due to compositional changes. I wish we could measure sort of the LEHD equivalent, but we don't have that data here.
Okay, a few more questions are coming in as I speak. Why not use 50-10 ratios as alternative measures of wage inequality to reflect the impacts on low-skilled and routine workers?
Absolutely. I don't think we've ever done that. There's no reason why we don't. As I mentioned, I do think these 90-10, 50-10, it's a little tricky within a given establishment using wage bins, but absolutely, we will add that to the list to do for the next time.
Okay, regarding increases of wage and inequality, do high-skilled workers' wage increases drive the results? Or
yeah, and I will show you that soon.
Okay. Are you able to observe a substitution of labor across establishments post-merger? That is, could the results of non-engineering high-skilled labor simply be a reallocation of the high-skilled workers, for example, researchers, to the acquirer's headquarters?
So we do, in results that I'm afraid I am not going to have time to get at, we do combine acquire and target, and we do find the same results. So
Okay.
it is not just simply a reallocation.
Are wage increases due to inflation?
So we control for inflation.
That was the last question.
Okay. Okay, so pre-trends with any diff and diff, this is important to show. Now remember with the OES data, so this is survey data, and establishments are not surveyed every year. In fact, they are never surveyed more often than once every 3 years. And most establishments in our data are just simply going to be observed every 3 years. That's the most common pattern we're going to observe. So when I'm looking at pre-trends here, don't think of this as -1 is going to be 1 year prior. This is going to be the first observation before the pre-year. And then pre-2 M&A is going to be the second nearest observation prior to the pre-M&A year. And so just looking at maybe the RTI column, there's no evidence of sort of a decline in routine task intensity for our treated firms relative to our control firms. So same thing with share high tech wages standard deviation. So for all of those, we find an increase following the M&A. We find no evidence of an increase pre-M&A. But I think sort of more interesting are going to be these tests that we're going to do where we're going to really try to separate from this omitted variable story that's already been brought up in one of the questions, which is sort of the concern you would have here is it could just be that there's some common shock, and that common shock is going to drive both M&As and it's going to drive labor market reorganization, but it is not that the fact that firms are doing the M&A in order to achieve the labor market reorganization. So as I've mentioned before, I think our main result against this is the fact that adding those industry year controls, which completely, I'm not trying to argue are sort of a perfect absorption of this concern, but they should be highly correlated with this concern. And if it was driving our results, then adding these should have a dramatic impact on our coefficients of interest, and it does not appear to be so in the data. But we're going to do two other things. So sort of the standard thing that a lot of people do with M&As, we're going to look at exogenously canceled deals. I think this is a super clean test. The problem is finding exogenously canceled deals that are canceled for reasons unrelated to the labor markets at the target and are in our OES data. It's going to be a small sample, but we do what we can. The other thing we can do is if you have in your mind, you know, it can't be something, a concern that there's something just inherently different with the treated firms, the M&A firms, because everything we do, we have M&A establishment fixed effects. But it could be a concern that there's something to do with those M&A firms, excuse me, at the exact year where they're acquired. And so in order to do that, absorb that, what we could do is include establishment year fixed effects. That would completely pick up any of this worry. But obviously, the only way we'd still be able to identify anything in the presence of establishment year fixed effects is if we have to have variation within establishment year. And so what we do here is we're going to take our sample, and for each treated and each control establishment, we're going to create 2 observations per year. So one will be for the routine employees, one will be for the non-routine employees. And so here, we just follow the existing literature, which says that if you're in the top 1/3 by routineness, you're considered routine. And then if you're in the bottom 2/3 by this measure of routineness, you're considered non-routine. And then we're going to do the same thing with high tech versus non-high tech. And so here first is looking at the within establishment outcomes. So here we have establishment year fixed effects. 2 observations per establishment year, 1 for the share of workers that are routine, 1 for the share of workers that are non-routine. And what you see is there's a greater decline in the share of workers that are routine relative to the share of workers that are non-routine post M&A. We also find a negative coefficient on wages. suggesting wages decline more among the routine employees relative to the non-routine employees, but it is not statistically significant. And here we do the same thing, looking at workers within this high-tech occupations versus non-high-tech occupations. What we find here is the relative share of high-tech workers increases more compared to the share of non-high-tech workers, again, at treated firms post M&A. And here, this gets back to somebody's question earlier. We do find this really strong wage effect. So this is now about a 5% wage effect relative to before. Across the whole sample, we were observing this about 1.5% wage effect. And that is concentrated at the high-tech workers relative to the non-high-tech workers at M&A treated firms in the post period. Is there a question on this test before I move to the next?
There is a question that just came in. At a broader level, do you have some policy implications in mind? Not obvious to me whether a social planner would be able to improve on this kind of transformation that is making the economy more efficient.
Yeah, so we've thought about that. I think the big question is our M&As speeding up the adoption of technology? Would it have occurred otherwise? And if it would have occurred otherwise, you know, how much is it speeding it up? And then in return for that, you could sort of think about, well, there's all these costs of sort of the reorganization and the integration that come with M&A. Is this the most efficient way to kind of get the technology into the firms? We aren't going to make a stand on that. But I think it is interesting to understand how technology sort of gets into the economy when are firms making this choice to sort of increase their investment in these types of technology. And certainly M&As is not the only mechanism through which they're doing it, but it seems to be that we have strong evidence that this is one of the mechanisms in which the speed of technological investment increases, at least. Okay, so in terms of the canceled M&A deals, so here we read all of the announcements for all of the canceled deals. We identify those where we believe they are canceled for reasons that would not otherwise have any implications for the target's labor. And we come up with two types of canceled deals. One is regulatory action, and the other is the acquirer itself gets acquired. So what is really nice, I mean, this test could be perfect in the sense that if you're worried about some omitted variable and that target establishments are just inherently different at the exact time that they become targets, well, these are target establishments too. So they should have that same, whatever selection bias you're thinking of, that should also be there. It's just the M&A does not end up being completed, and so we can separate between the two. The problem is at the end of the day, we have a very small sample here. So I think they're interesting. I think they're consistent with the arguments we're making, but it does come with this caveat that we fully admit it's a small sample. So here's what we do. The same for variables. We don't include state times year fixed effects, again, just because the sample size is small, but we've looked at it. It's relatively similar. And what you see is with RTI, now with the set of canceled deals, it's not significant and it's quite close to zero. With wages, it's negative. What we find with the completed deals is it's positive. With standard deviation of wages, it's negative. With the completed deals, it's positive. With share high tech, it's negative. With the completed deals, it's positive. So we don't find any consistent results when looking at these canceled deals. Again, concern is the sample size. This is about 2% of our baseline sample. So one thing we've done is we've gone back to the true data and just subsampled 2%, 1,000 different times, and tried to see what we get. Do we replicate the results we get in the broader results? Absolutely. So this is somewhat comforting that it's not simply the fact that we're getting these null findings in the other results are driven by the fact that they're just different. Without the M&A deal being completed, we're not seeing the same effect. And so we do the same thing with RTI, high tech, wages, and standard deviation of wages. Okay, so I have one last main set of results. which is everything I've shown you so far is at the establishment level. And I think one question already has sort of brought this up, which is you could see these results at the establishment level, but they could just sort of be being backed out. So you could think of a scenario where, let's say, one target firm in industry X gets acquired and it releases all of its workers in high routine occupations and employs these additional workers in high tech occupations, but its competitor peer just does the reverse, because now there's all these routine occupation workers in the economy that are available at a cheaper price. So it simply hires up the routine workers and it hires less high-tech occupation workers because they're now more valuable and harder to get. And the net effect on the economy is not to actually change anything, because whatever happens at the target firms is effectively getting backed out at their peers. So to try to get at this, we're going to look at economy-wide data. So we're going to use IPUMs. Now, the issue with using IPUMs is in order to get the sample that has enough data that we sort of have a viable sample size by industry occupation, we have to use the data that's only available every 10 years. So this is an anonymized 5% extract of the decennial census. This is all publicly available. Anyone can get this from the IPUMS website. And this is going to give us information on employment, wages, education, geography, and occupation. So anyone who's worked with IPUMS data is aware of the fact that occupations and industries are defined differently in the IPUMS data. And so that's because the purpose of this is to be able to kind of understand how America's changing over time. And so they want to define these occupations and industries that are not going to be changing much over time. And so what we're going to need to do is we're going to need to map in our industry, which are going to be NAICS, into these IPUMS industries. This is not a straightforward task because it's not a one-to-one match. So if you want to look, we have more detail about this in the online appendix of the paper as to how we do this match. Essentially what we do is we aggregate IPUMS industries and we aggregate NAICS industries until we can get to the point where we can do a one-to-one match. And to do that, we end up with 132 industries, and this includes about 80% of the NAICS industries. So in terms of the IPUMS summary statistics, the main variable that's going to be important to keep in mind is this measure called merger intensity. This is going to be measured, we just take SDC and we look at the past decade. So the 1990 column, this is going to be the count of mergers that occurred between 1980 and 1990 in that industry, divided by the total count of mergers that happened in that decade across all industries. Now, the regression results I'm going to show you in the next slide, they have industry fixed effects, so that will control for the fact that some industries are bigger than others. And we're just going to be using identification based on the fact that maybe in one industry there were less mergers in the 1980s, while in another industry there were more mergers in the 1990s. Then we're going to measure our same measures we have everywhere else: routine task intensity, high-tech employment share, average hourly wages, standard deviation of hourly wages, and offshore ability. And let me show this result, and then I will get to, I think a couple questions came in. And here, again, those same 4 variables we've used everywhere else. We're going to look at RTI, high-tech wages, standard deviation. We have year fixed effects, industry fixed effects. Now, I can't do year times industry fixed effects because that's where my identification comes from. But it's interesting to see that we're finding the same effects here. So we see this decline in routine task intensity, an increase in the share of high-tech workers, a mean increase in wages, and increase in the standard deviation of wages. I think there were a few questions.
Yeah, 2 questions. What about any heterogeneity in acquirer and target of canceled deals versus those that are not canceled?
So the summary stats of the canceled deals relative the canceled deal statistics. We have a table with that. I did not put them into the slides. Gosh, I don't want to misquote. nothing was so different that it made us concerned. But yes, we have that, and it will be reported when we update the next version of the tables. That's fair to think about.
Okay, since, is it IPOM or IPUM, is from 1980. So how do you get the information about occupations in year 1980 if the data for occupations is, I believe, 1990?
So what we're doing with the IPOMS data is we have the census data from the decennial census in 1980, and we have the data from the decennial census in 1990. And in those census years, we have information on occupation. For each of those occupations, we can map it to the Otter and Doran measure, which is based on this original dictionary of occupational titles, which actually comes from, I think it's the 1977 edition is the one that they've originally based it on. And so that's how we score the routine task intensity, and it's the same everywhere.
Okay, there's another question that just came in. You've got about 5 minutes. Do you
Yeah, I
want
just
to take
have one more slide, so I'm
okay,
good.
so let's take, I'm not sure how the IPOMS data helps. It seems like you have a set of macro time series that are correlated in time. RTI and high-tech share are likely to increase, and we know that mergers have increased over time. How do we know that there's a meaningful relationship between them?
So absolutely. I mean, this is at the end of the paper because it's not the strongest results in our paper. I don't think it's as simple as this questioner is alluding, mainly because remember that measure of merger intensity, we normalize by the total count of mergers. So this can't just be driven by just total merger activity. This is driven by relative intensity in a given industry versus another. But absolutely, this is purely correlations. I think it adds to our paper in the sense that, again, if we're trying to argue that this is sort of an important mechanism, an important catalyst through which technology enters into the real economy and firms make these decisions to invest more in technology, then I think we do need to show that it has some sort of implications beyond just the target establishment. But we absolutely see all the weaknesses of this data. And so this is why it gets presented at the end. In a previous version of the paper, we did a bunch more robustness tests with this data. But at the end of the day, I think, it is what it is. It is consistent with the story we're trying to say, but we don't want to overinterpret it.
Okay, that was the last question.
Awesome. Okay, so to conclude, we show that labor reallocation and wage changes following M&As reflects this change at the target, which would be consistent with greater technological adoption. I think relative to the existing literature talking about how M&As change target labor, we're showing that the impact is more nuanced, that there are some winners and there are some losers. So for example, what we're finding is that the opportunity set for workers that are engaged in sort of high skill, high tech occupations probably increases because with more technology, they're able to become more productive. On the other hand, this clearly is negative for workers that are employed in highly routine, intensive occupations. I think it is nice that we observe similar results across two very different samples at the establishment level, at the industry level. And then, of course, one big caveat, we are only able to make these claims about workers who remain employed either in the establishment or in the industry as a whole. We can't account for anything like unemployed workers or underemployed workers. So if there are no more questions, then thank you, everybody. These were a lot of great comments, and this will be very useful for us as we start a revision process.
Paige, there was one question that just came in. Regarding the matching procedure, is it possible that matching within industry is problematic? Assuming M&As happen in waves, the control firms consist of firms that were not acquired and potentially lost market power and cannot invest at the same level as the larger combined firms.
Oh, that's interesting. I had not thought of that. We have done a couple of different matching, but I think we've always started with an industry matching, but absolutely, we could do a robustness where we don't do an industry matching. One other way that might be a little bit easier to get at this would be we could do a matching where we require that the matched control firm is not necessarily in the same market area. One of the things we don't really use is geography. So that way we could probably get at some firms that are not directly competing. That is something certainly we'll add to our list to do.
Okay, well, great. We'd like to, on behalf of Nuri and Andre, we'd like to thank you, Paige, for the great presentation, and for all of you that participated, asked questions. We appreciate it. So we are going to be skipping next week because of the cavalcade. We are going to resume on Tuesday, June 2nd. Eric Zwick from the University of Chicago will be presenting his paper, Top Wealth in America, New Estimates and Implications for Taxing the Rich. Again, thank you, Paige, and we will see all of you in 2 weeks.
Thank you.